This video is for solving a system by a new method called elimination. You've already learned two methods for solving a system, graphing and substitution. This is a third method, and this one you might find handy when equations are given to you in standard form, where there's no obvious x equals or y equals, or when you wouldn't want to graph it. So let's take a look at three examples here. First example, we have 2x plus 2y equals negative 20, and 2x plus 4y equals negative 24. And what I realized right away that both equations have a 2x in them. And what I'd like to be able to do is to take advantage of the fact that there is a 2x in both equations. So what I'm going to do here is, if we have the same term in both equations, we'll be able to subtract. And what I mean by that is, we can take these two equations and subtract straight down. I'm going to keep track of where my equal sign is here, but I'm going to subtract the second equation from the first. And here's what happens. If I take 2x and I subtract 2x, well, that's kind of nice. They cancel each other out. But how about 2y minus 4y? Well, that's negative 2y. And how about negative 20 minus negative 24? Well, we have to be a little careful there. I have negative 20 minus negative 24. That's the same as negative 20 plus 24. That comes out as 4. So I have 2y, I have 4, and I have an equal sign. Negative 2y equals 4. I can divide by negative 2 now, and I see fairly easily that y equals negative 2. Well, now how do I get x? Well, the idea is if I have a y, I can plug this into either of the two equations and figure out what x is. I'm going to plug it into the first one. I have 2x plus 2 times negative 2 is y. That equals negative 20. Just a little work here. 2x minus 4 equals negative 20. Add 4 to both sides. 2x equals negative 16, and you can see that x equals negative 8. And that's what x is. So therefore, the solution to this system is the ordered pair negative 8, negative 2. Okay? So subtracting down comes in handy sometimes. Here's a second example. 8x minus 6y equals 12. Negative 3x plus 6y equals negative 27. This time, I have things that aren't the same, but they're pretty similar to each other. I have a negative 6y and a positive 6y. And I would like those to eliminate each other. The idea here is if I have things that have the opposite signs, so opposite terms, well, if I wanted to get rid of those, I would want to add them. So I'm going to add down in this situation. And watch what happens when I do that. I'm going to add the second equation to the first. 8x plus negative 3x, that is 5x. Negative 6y plus 6y, they cancel out. That's nice. They eliminate each other. That's why we call this method elimination. 12 plus negative 27, that's negative 15. I can divide both sides by 5, end up with x equals negative 3. Kind of nice. Now I'm going to take that negative 3, I'll plug it into the first equation. 8 times negative 3 minus 6y equals 12. I have negative 24 minus 6y equals 12. Add the 24 to both sides. I have negative 6y equals 36. Now I divide both sides by negative 6, and I have y equals negative 6. So there is my ordered pair, negative 3, negative 6. All right, two examples down, one more to go. 2x plus 3y equals 16, and 7x plus 6y equals 29. Unfortunately here, I don't see any terms that match up. I don't see any terms that are opposites or the same that I could add or subtract down. But I'm going to do something a little crafty here. I have a 3y and I have a 6y, and I want them to be the same. So here's what I can do. I'm going to take that first equation, I'm going to multiply it all by 2 using the distributive property. I'm going to write it over here. So if I multiply everything by 2, I get 4x plus 6y equals 32. And that second equation I'm going to leave alone. 7x plus 6y equals 29. Can you see now why I multiplied that first one by 2? Well, the idea is I now have 6y and 6y. Since they're the same term, I can subtract down and they'll be eliminated. So I'm going to do just that. I'm going to subtract the second equation from the first. 4x minus 7x, that's negative 3x. 6y minus 6y is 0. And 32 minus 29 is positive 3. Well, that's all set to go. I divide both sides by negative 3, and I have x equals negative 1. All set to go. Take that negative 1, plug it into either of the equations. I'll plug it into the first one. 2 times negative 1 plus 3y equals 16. I have negative 2 plus 3y equals 16. Running out of space. I'm going to add 2 though. 3y equals 18, therefore y equals 6. So my ordered pair is -1, 6. So this new method of elimination comes in handy for the most part when you have an equation that is given to you in standard form and you don't want to solve for x or for y. So consider using it, and we'll do some practice together.